Hello students, welcome back to our channel Diksha Karnataka. So your COMEDK 2024 examination is approaching. So in this video, I'll be discussing all the important formulas from physical chemistry where you can expect majority of the questions. So the task you have to do is you have to take a notebook or a A4 sheet and you have to note down chapter wise. I'll be discussing all the important formulas. So if you haven't prepared your any short notes, please write it down. And if you have prepared, just check once that you do not miss any important formula, right? So let us start with this very important session on physical chemistry. So let us see the first formula. Okay. First let us see what are the important or high weightage topics in physical chemistry. Okay. So solutions is one of the most important topic, then kinetics, then electrochemistry. These three topics are from your PU2, which are very, very important, and then equilibrium and thermodynamics. Okay. In your KSET exam, less questions were asked, but in your COMEDK from both the chapters, a lot of questions are asked. Okay. And then structure of atom. Okay, this is a very important concept. Let us go to the first topic, that is solutions chapter. So in solutions chapter, the first one which is very, very important is your concentration terms. Okay, so in concentration terms, we have three important formulas, that is molarity, molality and mole fraction, right? So molarity formula you can see here, everyone. W2 by W2 into 1000. So W2 is what? Mass of the solute. M2 is the molar mass of the solute into 1000 by volume of the solution in milliliter. Now, if it is in liter, we can just write W2 by M2 into 1 by volume in liter. Okay. One more thing that you have to remember, some unit conversion, 1 centimeter cube should be equal to 1 ml. Okay, and 1 decimeter cube is equal to 1 liter. Okay. In question, sometimes decimeter cube and centimeter cube units are also given, so you should not confuse there. Okay. Now coming to molality, so W2 is the mass of the solute, M2 is the molar mass of the solute, and W1 is the molar mass of the W1 is the mass of the solvent, right? So what I'll write here, W2 is mass of solute, M2 is molar mass of solute. I hope all of you will be knowing these formulas because it is there in your even in the first chapter, and W1 is mass of solvent. Okay. Now this mass of the solvent should also be in kg. Okay. If you are multiplying 1000, it has to be in gram. Molality is represented with small m, molarity is represented with capital M. I hope both the formulas are very clear. Now mole fraction, suppose we have a mixture of A and B, and I want to calculate the fraction of A in this mixture. So you have to just take number of moles of A divided by the total number of moles of A plus total number of moles of B. Right? That is what is mole fraction. Easy. Now coming to the next important factor or the most important topic in the solutions chapter is the colligative property. We have four important colligative properties. The first one is relative lowering of vapor pressure. So P0 minus P by P0 is equal to XV. So what is this? Whenever you add any solute to a solvent, the vapor pressure will decrease. So what is the P0? P0 was the pressure when you didn't add any solute, right? So P0 is your pressure of pure solvent. Okay. Then P is the pressure after adding the solute, and P0 is again the pressure of the pure solvent. XV is the mole fraction of the solute added. Okay. Next, coming to elevation in boiling point. So this is your delta TB is equal to KB into M. So M molality formula is this one. KB is your molar elevation constant. Delta TB is the increase in the boiling point. Now coming to depression in freezing point, delta TF is equal to KF into M. Again, this is the molality formula. KF is your depression constant, and delta TF is the freezing point depression or the difference. Now coming to osmotic pressure, in osmotic pressure we have molarity, C into R into T, where C is the molarity. So W2 by M2 into 1000 by volume into R into T, right? Here two more formulas I want to discuss. One is your Raoult's law formula. Okay, according to Raoult's law, the P total is equal to P0A XA plus P0B XB. Okay, and one more is your Henry's law. According to Henry's law, pressure of the gas is equal to Henry's constant Kh into mole fraction of the gas. Okay, so these two formulas are also widely used. Questions are asked from here, but colligative property is the major, like most of the questions will be from this part. Now coming to another factor or another concept where numericals are asked is your Van 't Hoff factor. So there will be dissociation or there can be association. So degree of dissociation is calculated by I minus 1 by n minus 1. So what is n? N is the number of particles formed after dissociation. Like for example, if you have Ab21 ion, it dissociates at A plus and 2B minus. So number of ions produced is 2 here and 1 here, that is 3. So n minus 1, n value will be 3 in that case. Similarly, association is I minus 1 divided by 1 by n minus 1. Okay. So these were the important formulas from the chapter solutions. So let us go to the next chapter, that is your chemical kinetics. So in chemical kinetics, first you should know how to write the differential rate law. So differential rate law is like for any reaction, if you have A plus A gives B plus B gives C plus C, in that we can write minus dA by dt, right? 1 by A of minus d by dt is equal to 1 by B of dB by dt is equal to 1 by C of dC by dt. This is equal to what? This is equal to rate of a reaction. Now here you have to remember that for reactants we have to use the minus symbol and for the products we have to use positive symbol. Okay, so that is done. Now coming to integrated rate law for 0th order and for first order, you must remember. So for 0th order it is K equal to 2.303 by T log of A naught by A, where A naught is the initial concentration, right? A is the final concentration, okay, initial concentration, and T is the time and K is your rate constant, right? Now for 0th order, I'll also note down here. For 0th order it is A naught. So please note down with me. For 0th order, A naught minus A is equal to KT. Okay, right? So let us number them. So first formula you have to write down is your differential rate equation. Second formula, give the heading integrated rate law. Under that for 0th order, this is 2, I can write 2 1 and this is 2 2. Okay. Now coming to third equation, that is your Arrhenius equation, most important formula in third Arrhenius equation. Log K2 by K1 is equal to EA by 2.303 into R 1 by T1 minus 1 by 2. So, but if you have seen the previous year papers, we have solved top 30 questions of chemical kinetics where we have taken previous year questions. No question was asked based on this formula, okay. So what you can do is you can just do the, like, remember this formula, do practice some questions, but most of the questions were from this integrated rate laws, and differential rate law was like lot of questions were asked from differential rate law. So this is what an important formula, you can remember it, Arrhenius equation. Next, so what is K2? K2 is the rate constant at temperature T2, K1 is the rate constant at temperature T1, EA is your activation energy, R is the gas constant. What is the unit of R you have to take? R should be 8.314 joule mole inverse Kelvin inverse. And in this one, in osmotic pressure, you should take the R value as 0.083 liter ATM mole inverse Kelvin inverse. Okay, clear? Okay. Now coming to half-life, again half-life also for first order only the formula is important, 0.693 by K, but I'll also note down for 0th order. For 0th order it is A naught by 2K, right? So this is for your 0th order. Okay, now let us put the next one. Yeah, now coming to electrochemistry, the third important physical chemistry chapter. So first is your Faraday's law, M is equal to Z into I into T. This one you have to use whenever the question is asked, how much mass will be deposited. Now if you see what is Z here, Z formula is molar mass, okay, molar mass divided by N into 96500. Whose molar mass should be taken? The mass which is getting deposited. Copper is getting deposited, copper molar mass you have to take. Silver is getting deposited, silver molar mass has to be taken. So here also you should remember the molar masses of some important elements, that is 63.5, silver is 108. These questions, these two are generally asked, so please remember their molar masses. Next, Faraday's second law also questions are asked in your COMEDK exam. We have solved top 30 questions of electrochemistry also. There you can see many 2 or 3 questions were there from this topic also. So m1 by m2 equal to equivalent weight of 1 by equivalent weight of 2. Now how to calculate equivalent weight? Equivalent weight is nothing but molar mass by n factor. Okay. So that is the Faraday's law. Now coming to the second topic here is conductance. Under conductance, first is your kappa value. Kappa is your 1 by R into L by A, where R kappa is what? Specific conductance. Okay. We have different names for this which confuses the student. So first is called as specific conductance, or it is also called as conductivity. Okay. Now unit of this one is S centimeter inverse or S meter inverse. Okay. Now that is first done. Then we have molar conductance. Molar conductance is equal to kappa into 1000 by C. Now here also I will remind one thing. If the unit of kappa, this formula you have to apply if the unit of kappa is S centimeter inverse. Okay. If the unit of kappa is S meter inverse, then the formula of molar conductance will be kappa into 1000, kappa by 1000 into 3. Okay, this is the formula of molar conductance when kappa unit is S meter inverse, right? So how many formulas we have written? 1, 2, 3, 4, 1 and 4b. Okay, now coming to Nernst equation, very important formula. E of the cell will be equal to E naught of the cell minus 0.059 by n log of product concentrations, product ion concentrations to the power of x by product reactant ion concentrations to the power of y. Here x and y are nothing but their stoichiometric coefficients. Okay. And one more thing what I wanted to say here is how to calculate E naught of the cell. E naught of cathode minus E naught of anode. Okay. So now let us see. Okay. Here we have to add some more formulas. 2 more important formulas I will tell you. One is when equilibrium conditions are there. Okay. For equilibrium conditions, okay, if you see, under equilibrium conditions, what happens? In the Nernst equation, if you see this part, E of the cell becomes 0. At equilibrium, E of the cell is 0. So what I will get? E naught of the cell is equal to 0.059 by n log of, here this ratio will be now called as equilibrium constant. So that is log of K. Okay. And one more formula is there for delta G. Please write that one also. Delta G is equal to minus NF E naught of the cell. So let us count the number of formulas. Here we have, so that you can remember, 1, 2, okay, and then you have here 3. This is 4a and this is 4b, where the units of kappa will be different, the formulas will be different. Then you have 5th Nernst equation. This one is inside that, you have to remember. Then we have 6th formula here and 7th formula here. Most of the numericals will be solved within these 7 formulas. Just go to the top 30 questions or previous year questions and solve them and check how many formulas you have remembered and how many questions you are able to do it. Okay. Okay. Now let us go into the next topic, that is your equilibrium. So very important topic, equilibrium from PU1. In case that questions were not much asked from this chapter, but COMEDK asked questions from this chapter. And easy to score, you just need to know, like very basic questions are there, but it has certain formulas are more. So in equilibrium, first of all, if you have any reaction of the formula AA plus BB gives you CC plus DD, then the equilibrium constant formula here is product concentrations, okay, raised to their power of stoichiometric coefficients divided by A to the power of A, E to the power of B. Right. So this is the value of equilibrium constant. Now one more is there. The same thing can be written in the pressure form if the A, B, C, D are gases. So same thing, pressure of C to the power of C, pressure of D to the power of D by pressure of A to the power of A into pressure of B to the power of B. Clear? So these two are done. Now one more question, one more formula is also there, rarely it is asked, that equilibrium constant is equal to rate of forward reaction by rate of backward reaction. Okay. So note down these values. So how many formulas till now done? 1, 2 and then 3. Okay. Now let us go to the next part. Next is your relation between Kp and Kc. This is 4th formula. Kp into is equal to Kc into RT to the power of delta Ng. What is this delta Ng? Here, this gas, this is the difference in the moles of gases. Like for example, if you have a reaction, 2A gas gives 3B solid plus C gas. So what you have to do, you have to calculate the change in number of moles of gases. Okay, so we have 1 C, that is on the product side, the number of moles of gas is 1, and on the reactant side the number of moles of gas is 2. So 1 minus 2 is equal to minus 1. So delta Ng will be equal to minus 1. Are you getting what I am saying here? This one, product we have 1 mole and on the reactant we have 2 moles. Only gas I will consider, this one is not considered since it is a solid. So like that we have to calculate the delta Ng value. Okay, so this is the first. So these are 4 formulas are there from your chemical equilibrium topic. From here the formulas that starts is for your ionic equilibrium. Okay. So under ionic equilibrium, first is the calculation of pH. Okay. So all of you know how to calculate pH, minus negative logarithm of H plus, right? pH is equal to minus negative logarithm of H plus. Now this is important. For example, you are having 0.1 m H2SO4, 0.1 m HCl. Okay. Now these both are strong acids, right? So what will happen? From 1 mole of H2SO4 we are getting 2 moles of H plus. So from 0.1 I will get 0.2, right? So the concentration of H plus will be 0.2. We can directly substitute here. Now similarly here, from 1 mole of HCl I am getting 1 mole of H. So from 0.1 mole of HCl I will get 0.1 mole of H plus, right? That also we can substitute. But what if we have 0.1 molar of CH3COOH? In this type, when this is a weak acid, we cannot consider that the number of moles of H plus is also 0.1. Okay. In case of weak acid, since the dissociation is less, we cannot assume that all 0.1 mole of CH3COH will give you 0.1 mole of H plus. So in that case, this formula comes where the H plus concentration is root over of Ka into C. So for every weak acid, Ka value will be given to you, concentration value will be given to you. The only thing you have to calculate is H plus concentration will be root over of Ka by C. Now once you get this, you can put that H plus formula here and get the answer. Okay. Now sometimes they also ask you the degree of dissociation. Like as I told you, they do not dissociate 100%. So if not 100%, it will be some percent like 40, 30, 20%. So how to calculate the alpha or degree of dissociation? Root over of Ka by C, where Ka is the dissociation constant and C is the concentration of the acid. Okay. Now coming to relation between pH and pOH. So this is very easy. pH plus pOH is equal to 14. Okay. Now coming to buffer solutions. So we have 2 types of buffer. So how the pH of buffer solutions are calculated? From the Henderson equation, right? In Henderson equation, for acidic buffer, okay. Now an acidic buffer is made up of what? Weak acid plus salt of weak acid plus strong base. Weak acid, salt of weak acid and strong base. Example, tell me. Weak acid, I will take CH3COH, CH3COOH. This is there, plus salt of weak acid and strong base. So if I take a weak acid is CH3COH and strong base is NaOH. So salt of this will give you what? CH3COONA. Right. So now this two composition will give you a buffer. Now if you see salt concentration is this one, we have to substitute here. Acid concentration we have to substitute here. Then pKa value we can substitute, that will be given in the question, and we have to calculate the pH. Similarly for basic buffer, this is the formula for basic buffer. Right. A basic buffer is made up of what? So if you see here also the composition is very similar. Basic buffer will be made up of a weak base plus a salt of weak base plus strong acid, right? So which is a weak base? NH4OH. And what is the weak base is NH4OH, and just assume any strong acid like HCl. So what I will get? NH4Cl. right? So this together will give you a composition or will form a basic buffer. So for basic buffer, the salt is NH4Cl and base is NH4OH, right? Okay, so this is how we can calculate. Now here also you should remember, generally for basic buffers they will ask you pH. Okay, so what you have to do, first you have to calculate the pH using the Henderson equation, then you have to use the relation pH plus pOH is equal to 14. So we have already calculated the pOH value and then you can calculate the pH value, right? Okay, now coming to salt hydrolysis. So salt hydrolysis we are having for three types of salt. One is weak base and strong acid. Give me your example. So weak base you can take NH4OH and strong acid is your HCl. So the salt will be NH4Cl, right? So if this is the its type of salt, what will be the pH value? 7 minus half pKb minus half log C. Okay. Now if it is a weak acid and strong base, so a weak acid and strong base is your, we can have example of CH3COONA, right? Here weak acid is CH3COOH and strong base is NaOH. So if they react, we'll get CH3COONA, right? In that case, the pH value will be 7 plus half pK plus half log C. Okay. Now coming to weak acid and weak base. So we can take this one. Weak acid is CH3COO and weak base is NH4, right? We will get minus plus, we can have, right? Now here also if you see 7 plus half pK minus half pKb. So here I can tell you one like formula. Whenever it is pKa, with that we have to, like, formula will be taking plus, and in terms of pKb it will be taking minus. You can see here minus half pKb. If pKb is there, the whole equation you can write minus log C. Then with pKa it is plus here, and here also it is plus. But if you see in this equation with pKa, again it is plus pKa minus half pKb. Okay, so this is in the formula. If you cannot remember, you can remember in this way. Now coming to, okay, this is actually solubility product formula. Okay, now in solubility product, for any salt of the type A to the power of X, AX, BY, okay, any salt is there, the solubility formula will be, KSP formula will be, let the solubility of A be S, solubility of B be Y. So we will have X to the power of X, Y to the power of Y, S to the power of X plus Y. Okay. One example if I tell you, like we have suppose MgCl2. Okay, so what is X value is this one, X value is 1 and Y value is 2, right? So now if you have take the formula X to the power of X, 1 to the power of 1, Y to the power of Y, 2 to the power of 2, S to the power of X plus Y, 1 plus 2, right? So what I'll get? 4S cube. Okay, so like that we can calculate the salt hydrolysis or solubility product. So these were the important formula based questions which you can expect from the ionic equilibrium and chemical equilibrium. One more here I'll add, like how we have for weak acid H plus concentration is root over of Ka into C. Similarly for weak base the OH minus concentration will be root over of Kb into C. Okay. One more thing, another topic which you must revise and go, that is a theoretical topic, is your Lee-Chatterley principle. Okay, so prepare this one thoroughly for all the important factors like concentration, volume, temperature, addition of inert gas, and then you have pressure, right? So all the 5 factors, or addition of inert gas under constant volume and under constant pressure, what is the difference? So just prepare this one. A lot of questions are asked from that topic also. Okay, let us see the next important chapter, that is your thermodynamics and thermochemistry. Again PU1 topic, but many questions are asked from here. But you need to revise certain formulas only to calculate or to get full marks in this chapter. So the first one is your first law of thermodynamics, delta U is equal to Q plus W. Here you should be very careful about the sign convention. So what does happen here? If heat is supplied, okay, if heat is supplied, then Q will be positive. If heat is removed, then Q will be negative. And what about work? Work done on the system will be positive, and work done by the system will be negative. So here, those, like in physics also you have thermodynamics chapter, the sign convention used there is different because their reference is different, right? So that is why please remember, when you solve, use this sign convention in chemistry. Now coming to enthalpy of reaction, so we can calculate the enthalpy of reaction in two ways. One is using the enthalpy of formation concept. So if formation enthalpies are given, then enthalpy formation of products minus reactants will give you the enthalpy of reaction. If the enthalpy of reaction comes out to be positive, it is an endothermic reaction. If it comes out to be negative, it is an exothermic reaction. Now what are the other way or other method of calculation of enthalpy of a reaction is using your bond enthalpy. Here you have to see bond enthalpy of reactants minus products is done. And here for the enthalpy of reaction, it is enthalpy of formation of products minus enthalpy of formation of reactants. Now how to calculate the change in enthalpy? That is delta H is equal to delta U plus del P delta V. And for any reaction, this is equal to delta H is equal to delta U plus delta Ng RT. Where delta U is internal energy, P is pressure, V is volume. Again delta U, R is gas constant, and T is temperature. Here one more thing you should remember, if isothermal process is there, for isothermal process delta U will always be 0, delta H will always be 0. Okay, please remember these two. Now going to the next one, work done formula, very important. Work done will be equal to minus 2.303 nRT log of V2 by V1, or in place of V2 by V1 it can also be P1 by P2. Okay, and one more formula is there, when work done is done under free expansion or work is done in vacuum. In that case, minus V external dV, this is the general formula for work done. Now in vacuum what happens? P external is 0, right? So that is why work done will also be equal to 0. You can remember this point. Next is entropy. Entropy formula is delta S is equal to delta Q by T. Then gives free energy, very important, delta G is equal to delta H minus T delta S. Many questions are asked from this formula. Here you should remember, for the spontaneity of a reaction, delta G has to be negative. Okay. So next is another PU1 chapter, structure of atom, from where also many questions are asked. So first is your hydrogen spectrum. You should be knowing each and every question from hydrogen spectrum. The series of this hydrogen spectra, Lyman, Balmer, Paschen, bracket P, from their N1 and their N2 values, in which case we will get shortest wavelength, when we will get the longest wavelength. So these all things you have to remember. So 1 by lambda is equal to RH is equal to 1 by N1 square minus 1 by N2 square, where RH is your Rydberg constant. The value of RH is 109677 centimeter inverse. Now coming to angular momentum, mvr is equal to nh by 2 pi. M is the mass, v velocity, r is the radius, n is the quantum number, and h by 2 pi Planck's constant, right? Next coming to radius of Bohr's orbit. For any nth orbit, the value of the Bohr's radius is 0.53 n square by z. Okay, where again n is the number, the shell number, and z is the atomic number. Okay. Next coming to de Broglie wavelength, again very important formula, lambda is equal to h by mv, or you can write h by p, right? And then we have Heisenberg uncertainty principle. The uncertainty in position, the uncertainty in momentum is equal to or greater than h by 4 pi. Okay, so this is also important in easy formula. Now energy of any, like we have the radius of any nth orbit, energy of any nth orbit is minus 13.6 z square by n square ev. Okay, unit is different, ev. Okay, next is your quantum numbers, very important topic. Principal quantum number, what is the range? It starts from 1 to infinity. Then azimuthal quantum number, L is equal to 0 to L n minus 1. And then we have magnetic quantum number, minus L to plus L, and spin quantum number is plus minus 1 by 2. So I'll give a small example from this one because questions are asked from here also. For example, we have a orbital 3p. Okay. Now in 3p, what is the n value? This is your n value, that is 3. What is L value? So if you remember, for S0, P1, right? So L value is 1. But L value ranges from 0 to n minus 1. So it is 0, 1 and 2. Okay. Now, for each L value, you will have a ml value. For each L value, there will be ml value. So, I'll write it in tabular form. Wait. If we have 3p, okay, N value is 3. L value is 0, 1 and 2. What is ml value? Minus L to plus L. So, for 0, minus L to plus L is 0 only. For this one, it is minus 1, 0 and plus 1. For here, it is minus 2, minus 1, 0, plus 1 and plus 2. Right? And spin quantum number is plus minus half. Clear this part? Okay. Now coming to notes questions. A lot of questions are asked from notes part. Okay. Very, very important thing. Nodes are the places where the probability of finding the electron is 0. Now, the nodes are of two types. We have angular nodes and radial nodes. So, radial nodes formula is n minus L minus 1. Angular nodes formula is L, and the total number of nodes formula is n minus 1. Okay. So, these were the most important formulas from all the high weightage physical chemistry topics for your COMEDK 2024 examination. So your task is to just revise these formulas. If you haven't written them, note it down, and if you have already made short notes, just check that you do not miss any important formula. Okay. So please prepare these formulas. It will be very, very helpful in solving most of your physical chemistry questions. And if you have doubt in any of the formula, just please comment it down. We will be addressing it in my next video. And if you have found this video useful, if you are liking the videos that we are creating for your COMEDK preparation, please like, share and subscribe our channel. It really motivates us. So thank you so much. Keep working hard for your exam and all the very best for your exam. Thank you.